Hi guys, in a previous video we talked about what complex numbers are, how to simplify them with expressions that involve radicals or powers, addition or subtraction. We're going to move on to the last material for the unit, and that's going to be about multiply and dividing with complex numbers and a couple of different things that are related. We're going to start with multiplying complex numbers though, and there are always a few different steps that you're going to want to follow if and when you are to multiply. So the first thing is to know, when do we multiply? And we're going to multiply whenever we have parentheses that are not joined by anything like an addition or subtraction symbol. So I have a couple of examples here where we have either a back-to-back parentheses that we're going to end up multiplying, or something in front of a parentheses. It's not being added or subtracted to that parentheses. We're instead going to distribute. The first thing to know is that we're going to need to multiply, and then choose a method of multiplication. So sometimes we can distribute, as we'll do in example 1 in a second. Other times, if we have two binomials that we're multiplying, two different parentheses with two terms in them, we're going to be using either FOIL or the box method. And I'm going to recommend one of those in a bit, but you are welcome to use either one. After that, we'll do some simplification of what occurs within those boxes or as a result of that multiplying, remembering things like I squared equals -1. We talked about that in our last video. And then combining like terms. So that is what we'll be doing to start today. We have a couple of examples of multiplying problems. The first one being one where we're distributing. So we're going to take whatever's in front of our parentheses and multiply it to everything inside of the parentheses. So two different times we'll be multiplying, and we're going to multiply numbers times numbers, i's times i's. So -7 times 4 will be -28. And don't forget that we have an I at the end. -7 times -8 will be +56. I times I will be I squared. So think of how we would multiply with variables. It's very similar to that process. That's step 1 and step 2. Figuring out we need to multiply, what method to use, actually multiplying, and then, okay, this is very important, I squared, I'm going to star this, I squared equals -1. It's very often the case that when you're multiplying involving complex numbers, this is going to show up. We're always going to substitute -1 in for I squared. So how is that going to look? Well, I'm going to rewrite my problem and then put a little arrow down to this. Okay? We're not subtracting by -1, we are multiplying by -1. So don't get that confused. It's not 56 minus 1, it's 56 times -1 because we're multiplying here 56 times I squared. To simplify that, a positive times a negative is a negative, so -56, and minus 28i. Remember to always write your answers in standard form. A plus BI form, right? Okay. I should always come last. And that is how you multiply by distribution. Another example of how to multiply. This is where you're going to have to make choice, okay, between the box method of multiplying versus FOIL. Either one will get you to the same solution. I'm going to show you how to do the box method because I think it's a useful way of organizing how to approach multiplication, and the benefit of it, as we'll see, is that it's hard to forget that there's more than two things that we need to multiply. I have a lot of students, if and when they use FOIL, or the arrow method in other words, they'll multiply first term times first term and last times last. That's not just what you should do. You should be multiplying 4 different times. FOIL has 4 letters, multiply 4 times. Yes, first, and yes, last, but also outer and inner. Okay, 4 different arrows, 4 different times. The box method is much easier to work with, I think. Okay, I'm going to draw 2 columns because we have 2 terms in the first parentheses, 2 rows because we have 2 terms in the second parentheses. So 5, positive 3i, 7, negative I. Now that I've organized the box this way, hopefully you see there's 4 different answers I should be getting here, right? For example, 7 times 5, 35. 7 times 3i, 21i. 5 times negative I, this is like an invisible 1 in front. So remember, we're multiplying numbers times numbers. Negative 1 times 5 is negative 5 with that little I. And lastly, 3 times negative 1 is negative 3. I times I is I squared. Don't forget that's I squared, not just I. I times I is like adding those exponents, invisible ones. 1 plus 1, 2. Product rule. Talked about that in our exponent rules section of the unit. So please remember that as well. Now we want to unpack our box. Okay, we've put everything in the box that we needed to. Now let's unpack it. We had a positive 35, a positive 21i, a subtracting by 5i, subtracting by 3i squared. Okay. From here on out, it's the same thing that we've done in the past. So first thing to remember, I squared is negative 1. Let's go ahead and rewrite the problem so that shows up. I like to draw arrows just to make sure that everybody connects that I squared is negative 1. A negative times a negative will be a positive, so we're going to end up adding by 3, right? 3 times 1 is 3. And then this now is just the same type of problem that we had at the end of last video, right? We have an addition problem with some subtraction. Combine like terms, right? This is where you're going to want to combine like terms. So we have a real number and a real number, imaginary part and an imaginary part. Combine those together. 35 plus 3 is 38. 21i minus 5i is plus 16i. So don't forget to use your calculator. Okay, I almost wrote negative 16i. So that should help you to avoid any careless errors. Follow these steps, always write in standard form, a plus bi, and that is how you're going to multiply with complex numbers. Now that we're able to do that, before we get to division, I want to remind you of order of operations. So this is going to be where PEMDAS, something that you saw maybe in pre-algebra or algebra 1, comes back into play. So we have parentheses, then exponent, then multiply, divide, then add, subtract. I had a lot of students in a couple of lessons today that wanted to multiply first. They wanted to immediately say, 5 is the first thing that shows up. I'm going to work with that 5 first. No, remember PEMDAS, parentheses first. Simplify inside if you can. And we can, right? 9i minus 6i equals 3i. That's the first thing that we should be doing. Okay, P, parentheses. Exponent next, so 3i squared, okay, that's our exponent. Remember, what does exponent refer to? How many times you multiply a number by itself. So we're taking that 3i and multiplying it times itself. That's going to be the same, by the way, as the power rule. Okay, you could distribute that 2 to multiply to both exponents, not 3 times 2, remember. That's 3 squared, 1 times 2, and then I squared. Okay. 3 squared, 3 times itself is 9, and don't forget that I squared is negative 1. So what that tells us is that our result so far is that we have a 5 times negative 9 plus 3, right? Negative 1 times positive 9 is negative 9. Now we can multiply, okay? So now we can take that 5, distribute it inside the parentheses. 5 times negative 9 will be negative 45. Only at the end do we add or subtract by 3. So negative 42 should be our result. Notice, by the way, that while we started with a complex part, we did not end with 1. And that's because I squared substitutes out with real number negative 1. Okay, something that you can find on the number line. This sometimes happens, and that's okay. It's just important to remember the order in which you solve your problem. If you try to solve it a different way, it's going to give you a different solution. And in that case, you might not end up with a real number. So be watchful of that, be mindful of that, follow PEMDAS. Okay, now we can start talking about division. Okay. How do you divide complex numbers? The first thing that we're going to do is to find what's called the complex conjugate. So, sounds weird, sounds complex. It's not really. The complex conjugate just refers to what is your denominator with a sign change in front of the part that has I. So step one here, I'll put it down here. Step one is to look at your denominator, which we said was 1 minus 3i. And maybe I'll make that a little bit clearer. Step one, 1 minus 3i is our denominator. What's the complex conjugate? 1 plus 3i. Okay. This is the complex conjugate for our problem. Why is that important? Because whenever, and you can choose any numbers in the denominator, whenever you multiply by the complex conjugate, what's going to happen, as you're going to see, is that i's will cancel out. We do not want to end with I in our denominator. That's why we're trying to simplify this division problem. We cannot end up with I in our denominator. Think back to Algebra 1 or pre-algebra or geometry when your teacher told you don't end up with a square root under a denominator, right, or in the bottom of a problem. Since I is the square root of -1, right now we have a square root in our denominator and we can't have that. So it's very similar to how you would simplify in the past with radicals. Okay. Multiply by the complex conjugate. So what we're going to do here is multiply 1 plus 3i to our numerator as well as our denominator. Okay. So I used the box method for the previous example. I'll go ahead and use FOIL for these, just so you have some variation about how to simplify with multiplication. And by the way, division of complex numbers is so useful because if you know how to do division, you really know how to do multiplication, you know how to do addition and subtraction. It combines all the different operations in one type of problem. So first thing, again, multiply by the complex conjugate after you find what it is. And in this case, first, so 8 times 1, those are the first numbers in your parentheses. Outer O of FOIL would be 8 times 3i, which is 24i. Inner, -2i times 1. Anything times 1 is the same thing. And lastly, last. So the last two numbers inside of these parentheses on the numerator, -2 times 3 is -6. I times I squared. Okay. Try to do the denominator on your own. Again, use the box method or FOIL. See if you're going to get what I get. So first, 1 times 1, very clearly a 1. Second, 1 times 3i. Outer of FOIL, 1 times 3i is just 3i. Inner, -3i times 1 is -3i. And some of you might be noticing, aha, okay, something just happened that popped up in our denominator that's going to let us to simplify in a second. But before I get there, -3 times +3, -9, I times I squared. Not just I, it's I squared. Okay. Now what was the aha moment that we just had? Well, we can simplify clearly our denominator by canceling these out. Okay. +3i, -3i, these are opposites. These cancel out. Okay, so I'm rewriting my problem here. Now I need to remember I squared is the same as what? You need to remember this on your own at some point. I squared is the same as -1. Times -1, not minus -1. Okay, so times -1 in both cases. Notice that a negative times a negative is a positive. Change the sign basically. Negative times a negative is another positive. And now we can combine like terms at the end here. Okay, we have 8 and 6, which is 14. Those are two real numbers. We combine these two in our numerator. 24i minus 2i is +22i. Okay, those are your imaginary parts. And in our denominator, 1 plus 9, right, because 9 times 1 is itself, 1 plus 9 is 10. Now, we're not quite done here. I know I have a lot of students in the past who have said, okay, this is my final answer. You're very close, but don't forget, I want you to always write your answer in standard form. So number one, that means a plus bi form. This is not an a plus bi form. Okay. How do we get that to be a plus bi form? Just separate your fractions, like so. Okay. Notice now I have a real number and an imaginary part, or real part and an imaginary part. But also this helps me because now I can simplify by a different method of reducing my fractions by a common factor or common multiple. In this case, what can I divide 14 and 10 by to reduce that fraction? I can divide both by 2. So 7 divided by 2 is the same as 14 over 10. All right, not by 2. That was to make sure you guys were paying attention. 7 over 5 is what I meant to say. Both of these things can divide by 2. 14 divided by 2 is 7. 10 divided by 2 is 5. Same thing with our second term, and this will be our final answer now. Divide both 22 by 2 as well as 10 by 2. Now our answer is in standard form, a plus bi. A, that real number, is a fraction, 7 over 5. Bi is 11i over 5, that's the imaginary part. And the coefficient there, if you wanted to go back to the last video, would be 11 over 5. That's the coefficient of your imaginary part. So those are the steps for division that you'll want to follow. That takes us to the last type of problem for our unit. And this one's a bit more simple. This is where we'll end with in our video today. Okay? And that is how to deal with equations. Now, it's not as difficult as it might seem. I think we might have even had something that was very similar in a previous video on rational exponents and radical expressions. It's about matching up the two sides of an equation in this case. So what I would recommend is that you match things that don't have I versus things that do. Okay? Both of these sides of the equation have to equal each other. So 10, in other words, has to equal 5x. And 21i has to equal negative 3yi. Well, how am I going to make sure that both of those line up? Okay. Well, in this case, I'm trying to find both x and y. I guess I got erased a little bit. I'm trying to solve for both x and y. So I need to isolate them on one side of my equation. So opposite operations, right? How do I get x by itself? Get rid of that multiplying by 5. How? Divide by 5 to both sides. Whatever you do to one side, do to the other. 5 over 5 is 1. Okay? So what does that mean? X equals 2 is 1 part of my answer, which makes sense because 5 times 2 will be 10. Okay? The other thing, and this finishes up the problem, solve for y. Divide by everything else that's next to y, because we're multiplying, opposite that is division. Divide by negative 3i, right? I over I cancels out, 3 over 3, negative over negative. But also make sure you do it to both sides. Okay? And if you do, you'll see that in this case as well, I over I cancels. And 21 divided by negative 3 is negative 7. So to double check your work, go back. Is negative 7 going to plug into here to give me my second term on the right-hand side? Yes. Negative 3 times negative 7 would be positive 21. Both have I. So that takes us through the last of our discussion on complex numbers and the last of the first part of our unit that we have. So if you have watched all the videos and done the practices for the exponent rules, how to simplify exponent expressions and radical expressions, rewrite them if you need to, as well as gone through our videos adding and subtracting, multiplying and dividing with complex numbers, and a couple of other simplifying problems that involve radicals and powers of I, you are all ready for the next step. So we will see you for that next unit.